So with law of cosines, as with law of sines, we can use this on any triangle, not just right triangles. And again, the most important thing is to remember that the angle and the side across from it have the same variable. Angles are capital and sides are lowercase. So law of cosines, if you are solving for a side, the side equals the square root of the other two sides squared minus 2 times the other two sides times the cosine of the included angle. So right here, what you need to notice is that the information you need in order to use law of cosines is either 3 sides or 2 sides and the included angle. Any other information you have about a triangle, you can use law of sines, as long as you have 3 pieces of information: angle, angle, side, 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 angle. For law of cosines, there are 2 different laws, one to solve for a side and the other to solve for an angle. You can use the first law to solve for an angle, and I've done that in the past, but students usually make a lot of algebraic errors when they're solving for the angle that aren't made if you use the second formula. So I would highly recommend memorizing both of these formulas for your test. So the formula to solve for an angle is, the first formula solves, square both sides, subtract b squared, subtract c squared, divide by negative 2bc, and then take the cosine inverse. Alright, so starting with solving for a side, which is a little bit easier, that formula is easier to remember and easier to use. And as a matter of fact, what I typically do when I give this formula is I have a squared equals without the square root on the other side. So if you can remember it with the square root, great. If you want to square both sides and get rid of that piece from your memory, it's still fairly easy to use. So a equals the square root of the other two sides squared, added together, minus 2. And I remember the 2 because there's 2 sides that we're multiplying, times 7 times 5, times the cosine of, and that angle needs to be across from the side we're looking for. And in our case it is. Punch all that in your calculator, being careful to use parentheses at the beginning and the end, and you should get the same answer that I did, which was about 4.950. To solve for an angle, again, if you have that second formula memorized, so in this case, r would be the cosine inverse of little r squared minus q squared minus p squared all over negative 2qp. So again, what you need to remember is the first side that you write down is opposite the angle you are solving for, and then the other 2 sides, order doesn't matter. So you subtract the square of the other 2 sides all over, again that 2, but we were subtracting it in the other formula, so it's negative, times the other 2 sides. So it's really not that hard to remember if you think about how they relate to one another. Alright, so inserting all of the information we have, side r is across from angle r, so that is 6. Order doesn't matter for the other 2. All over negative 2 because we have 2 sides we're multiplying together. And again, order does not matter because you're multiplying. You can multiply in any order. So again, being careful when you punch this into your calculator, you should get about 58.4 degrees.